My name is Melyssa Fratkin. I am the Industrial Programs Director at TACC. We are the research computing arm of the University of Texas at Austin. So we are fully a part of the university. Although we are not our own department, we service all of the departments with computing and visualization and software, increasingly software development support. We have about 160 people, about 70 of whom are PhDs in pretty much any science you can imagine. We have everything, I wanted to say aerospace to zoology, but we don't have any Z's. So aerospace to oceanography and some other amazing things in between. We have 12 megawatts of data center, housing about 15 different production systems for all different kinds of science. We have now, they've just built us a new office building that's about a year old. But in addition to that, we have people stationed in Houston and in Dallas to work with the other UT system institutions. The University of Texas system is statewide. There are 15 institutions, and we are just one of them, although we are the elephant in the room usually. We support all of them. We do at least 1 billion compute hours a year on all of our systems. Stampede is the one you have probably heard of. I will talk, that's Stampede in the second picture there. Stampede was number 17 in November. It's the first time in 4 years that it dropped out of the top 10, which made us very sad. But we are in the process of installing Stampede 2 as we speak, which will be, if I remember correctly, 4,200 nodes of KNL, and it is all going in with OPA as we speak. People are running cables and climbing ladders and doing all of that good stuff. So that will be open to early users coming this month, and then open for production by the end of the summer, and certainly we'll have lots of great users doing things by supercomputing. So we'll be talking about that in November. But as I said, we have about 15 different systems. We try to be technology agnostic, so while Stampede and Stampede 2 are Dell systems, Hikari is an HP system, Lone Star is a Cray system. If you'll notice from our naming conventions, everything is a Texas name. It's what we do. And the ones that we didn't name, Chameleon and Jetstream, you can tell we didn't name them. But Jetstream is our cloud computing system. So that is a system, it was on Irene's slide this morning. It's collaboratively funded out of the University of Chicago. I'm sorry, that one's Indiana. Chameleon is Chicago. Chameleon is an interesting system because it is a cloud computing research system. So that one allows the researchers to get bare metal access and build their own stack into the machine so that they can decide how do they want to run the cloud, not just I want to run my thing in the cloud. They're developing the cloud a little bit at a time. And that one's interesting for a bunch of different reasons, but it's 1,400 nodes between the two of them. So Stampede 2 is coming. We were funded by NSF to build it, and as I said, it's being built as we speak. 4,200 Xeon Phi nodes with OmniPath, eventually some more next generation Xeon by the end of the year, hopefully. And then in the future, some NVMe coming sometime when it's ready, probably next year. We do provide not just the high performance computing, we are not just the cloud for the researchers. We are increasingly software development, data intensive computing, data curation. We have a librarian on staff who helps with data curation. And so all of these capabilities are available to our industry partners. This is the 10th anniversary year of my industry partner program. Yay. I can't believe it's been 10 years, but we are under the University of Texas, and because UT has so many departments that have their own version of an industry affiliates program, they actually had a methodology of how you do this before I started. We are always the bastard stepchild, and I'm always asking them to do things that they've never done before. But, you know, for the most part, I do what they tell me. We have an annual meeting, a newsletter, we have quarterly meetings. We are doing more things in terms of giving consulting work to the companies who are interested in the new technologies. Because TACC is always pushing the envelope on what the new technologies are and what's available, our partner companies want to know, how does my code run on that? Or how do you think that is compared to this other thing? It used to be, how is Intel compared to AMD? Hopefully we'll get back to some of that maybe. But also FPGAs and ARM, we're looking at everything that's out there and how do codes run on those things. So for a base membership fee, our companies come in and they get access to our people and to some compute time for testing if they're interested in that. And then if they want deeper engagement, we do sponsored research agreements. And the staff, whoever is the lead primary investigator from our staff will depend on what kind of project it is. So we've done visualization projects, we do software development, we've done some LAMPS development, we've done work on Wharf. I've got some slides further on and the things that we've done. So it just depends on who on our staff can do that thing. And this is part of the study results is have the people who have that disciplinary knowledge to be able to work one-on-one with your companies. So for additional fees, they can get access just directly to our high performance computing, and some of them need help and some of them don't, and we're fine with that. But we also are helping now with data mining and large scale storage, which we have now, and some technology consulting, as I said. We have higher tiers of membership, which we're instituting now to give our partners more access to people. So for the most part, they'll come once a year and we'll have a big meeting and just bring everybody in and they can pick their brains. But for one-on-one meetings with our partners, they will come to TACC and we will bring in the high-level staff to a meeting, but this gives them it gives me more justification to take those people away from other things and have them come to these meetings. My NASCAR slide, I'm gonna get all this put on a jacket someday. I love this. But anyway, some of them are here, so thank you for being here. Our working sessions have been just a quarterly webcast and or in-person thing where the partners are asked, what do they want to talk about? And it's one of the things that we discovered back when I was working with Susie at the Council on Competitiveness. It doesn't matter which industry you're in, everybody has the same problems. And a lot of those problems are still around today. It's educating people, it's convincing your higher ups that you need to buy a supercomputer, and it's software. That was 10 years ago we did that. All those problems still exist. So all of these people still want to talk about those things and many others. And because TACC is pushing the envelope on these technologies, we have working sessions on these new things as they come up. So of course, before Stampede was deployed, we had a working session about Stampede. With Lone Star, which is a Cray system, we actually, we use the term jailbroke, but we'll say we went into the system and modified it to make it modular so that it runs the same way all of our other systems run. So that our users who are used to running modules that bring up the right compilers and the right libraries when they want to run their applications can do the same thing on a Cray, which it didn't do before. We've talked about green data centers. In the very beginning of InfiniBand, we talk about the difference in the interconnects. We talk about the different technologies and how they're impacting what we do so that you know how they might impact what you do. One of the biggest things that our partners have really wanted to do and have put up put their money where their mouths are is building the pipeline. Because we're not a department, we don't directly have a large cadre of students at UT, but we do teach classes in the university. So we are out there teaching Fortran and C every semester still, and every semester that class is full. And it's both graduate and undergraduate. We are also teaching an introduction to scientific and technical computing and parallel computing for scientists and engineers. And so we get these students in, and our partners are willing to then fund some of the things that we do with these students. So we almost always, I should say, have a student cluster challenge team, and our team won the challenge. It was 12, 13, and 14. And at SC, and so Raytheon and BP have alternated in funding our teams just to make sure that they can get to the competition, because that's actually paying for plane tickets becomes expensive. And then we've also had them sponsor interns who come and work at TACC in the fall and the spring, and then can go get an internship with the company. And Keith Gray can tell you, we sent him a couple of kids who finished their summer project in 2 weeks, and then they had to find them something else to do. So we're excited to train as many kids as we can to be computationally HPC literate for all of you to be able to hire them. Because we'd rather you do that than hire my staff. But anyway, we have just started, Intel. We have just started training, training institutes, which are week-long institutes in very in-depth and specific topics that we saw as being important. This week is the designing and administrating large-scale systems, so it's the sysadmin week at TACC. And this one was so popular that we had a waiting list that was as full as the acceptance list immediately, and we'll probably be doing it again in the fall. Computational techniques for life sciences. It's one of the large and growing communities in high-performance computing are the biologists and the life scientists who don't necessarily want to learn how to program in Fortran and C. And so we have people like Joe Allen, who you'll hear from tomorrow, who hold their hands, almost literally sometimes, and talk them through getting onto our computational resources. Data and information analytics and visualization are going to be joint in June, since they're sort of parallel and similar. We are doing computational science in the cloud in July. All of these are on our website. And then in the fall, we're doing HPC concepts for managers, which is talking to the people who are the bosses of the people who run the HPC to explain to them why HPC is important and why they should fund it, even though it's going to hit their bottom line for a quarter. And many other things. And that is going to be done collaboratively with our friends at the Numerical Algorithms Group, NAG, from the UK. What else? We have a special category for small companies. Under the previous governor of Texas, we had a thing called the Texas Emerging Technology Fund, where there was sort of a pot of money for small companies to make requests from the state and get some funding. And they were required to go in with a university partner. And so for some of these companies, that made it very useful to have a university partner that, oh, by the way, has a supercomputer they can use when they went in for this funding. So one of them was a company that was building aerodynamic things to go under tractor trailers. It was interesting. But we want to support workforce and economic development in Texas. Some of our projects, real quick, offshore oil platforms. Technip came into STAR in 2013, and in 2014 used 7 million hours on Stampede. It was so much more efficient than what they had. They could turn their simulations overnight, as opposed to, as Pete was saying, using the computers that they had overnight and hoping nobody logged in the middle of it. Technip, Firefly, which is a small rocket company that actually came to Austin partly because of TACC. And they did their first rocket test, last October. And they're back, and they did most of their CFD work for the rocket on Stampede. And then we did a project with Raytheon, where they funded us to look more closely and do some development on the Wharf Codes. We continue to do development on Wharf Codes. It's one of the things that's already running on the KNLs pretty well. And so that's another one where they used a lot of core hours, and we did some nice visualization, and that's actually been made into a much bigger movie. And I think, so our future plans, again, to continue filling that pipeline for you all so that you have HPC-capable students to hire. Early user program for KNL starts this month, and then more direct consulting for our partners to meet with them, one-on-one every year and figure out what we want to do in the coming year, how much interaction do we want to have, what do they need in terms of support from us computationally or personnel-wise. So I think I talk really fast, so if you have any questions, please stop me. We are on the path to Texas scale. It's what we call it in Texas. We're in Texas. That's what we do. So we are doing bigger, faster, and more efficient computing, powerful user application interfaces, and support for lots of diverse communities. Thank you.